Today we're going to talk about transformations of linear functions. So what I did was I began by graphing the parent function. This is just y equals x. My slope is understood to be the number in front of the x, which is 1. I could put a plus 0 here for the y-intercept. It crosses here at 0, 0. We can see it goes up 1 over 1, up 1 over 1, up 1 over 1, or we could go up 2 over 2, which is still going up 1, or we could go up 4 over 4, which is still 4 over 4 is 1. So my slope is 1. So this is called the parent function. Okay, so what I would love for you guys to do at this point is pause the video, get out your Chromebooks, get on Desmos.com and play around with this and see if you can figure out some rules. I mean, I'm going to proceed to tell you the rules, but I think you remember it better if you kind of figure it out for yourself. But let's look at what happens if I change, just keep the slope the same, keep the slope of 1, but I change the y-intercept. Well, we know that the line is going to cross the y-axis at whatever I change that y-intercept to be. So let's say I make it plus 2. What that does is it takes my parent function and it shifts the entire line up 2 units. Now notice, the blue line and the red line are parallel. They are never ever going to touch each other because they have the exact same slope. They're going up and over at the same rate. The red one goes up as the blue one goes up. They go over, up at the exact same rate. So my lines will never ever touch each other. So what do you think would happen if instead of putting plus 2, I put a minus 2 here? Obviously, the line would go down 2 units. So if I want to shift my line up or down, adding will shift the line up and subtracting will shift the line down. And this is called a vertical translation because we're shifting up and down, up and down. Vertical movement, right? You're moving it up, moving it down. This is a vertical translation. So again, how do we do a vertical translation? We do it by changing the y-intercept. We do it by changing the y-intercept. That moves my graph either up or down. Okay, so the other thing I would like to look at is how do we move the graph left or right? How do we make a horizontal translation? Well, there's a couple ways that we can do this, but the easiest way is to go in here and put this in parentheses, this x, and now we're going to do something to the x value. I don't want this minus 2 out here anymore. Instead, I'm going to put it inside parentheses. And look at what happened. This minus 2, yeah, it still shifted down 2, but it also, if we look at this point, it went over 2 units. So if I was to put a plus 2 inside of the parentheses, look at what happens. It shifts to the left 2 here as well. So if I subtract 3, and I'm just focusing in on this point, we would expect it to shift 3 units over here. And there it is. So if I want to do 2 types of translations, let's say instead of the parent function being here, I want it to go over 2, up 1. How could I do that? Well, I could minus 2 and add 1. And what do you know? This point went from here to here. Now I have a point here. It shifted over 2 units to the right because I did the minus 2, and it shifted up 1 unit. So what happens inside of the parentheses tells me if it shifted left or right. What happens outside the parentheses tells me if it shifts up or down. So inside the parentheses is known as the horizontal translation. So we have a formula that we use for this. We call it, let me open my little pen here. Oops, let's see. I think you'll be able to see this. I hope that you can see me writing on this. Okay, so when I have my little formula, this is called the function g of x is equal to x minus h plus k. we're used to seeing y equals mx plus b. It's kind of the same thing. But what this does is what's inside of the parentheses. This value of h tells me if my graph shifts to the right or to the left. You might have noticed that when I had x minus 2, that it shifted to the right 2 units. And you think, well, minus 2, that should shift to the left because it's going in the negative direction. But the reason that is because this minus is part of the formula. I actually plugged in a positive 2, so it went to the right. If I have x plus 2 in my parentheses, well, then what that means is I must have had x minus a negative 2, because remember the minus is part of the formula. So minus a negative makes it a positive. So this negative 2 is why it shifted to the left 2 units. And minus a negative becomes a positive. So when I write it, it looks like it's a positive 2, but that minus is part of the formula. So it was actually a negative 2, because minus a negative, again, is a positive. So this is shifting to the left 2 units. And then whatever my value of k is, that tells me the vertical shift. The value of k tells me if it shifts up or down. Okay, so that kind of takes care of that, this entire lesson. I mean, that sums it all up right there. We're talking about shifting right, shifting left, and this is something that is on the released test questions. It'll give you a function, and it'll say something like this. It'll say this is the parent function, the red one given. It'll be labeled. You won't be able to see the equations, but it'll label it and say this is the parent function. If the red line is the parent function, then what is how many units was the function shifted to get to the blue one? So you just look at the function and you say, okay, well, to get from here to here, I must have went up 2. So what we can do is just write that as g of x. Maybe we don't even know what the slope is or anything else, but we do know that they took the function. Let's say this red line is g of x, and the blue line is h of x. So whatever g of x is, we don't have to know the equation, but we can see that they did plus 2 to get to this point. So plus 2 equals the function h of x. So again, we can get the blue line by taking whatever the equation is for the red line. We don't even have to know what it is, and adding 2 to it, and that's going to shift it up. Or we could have looked at it and said, well, maybe it was a horizontal translation. Maybe it wasn't a vertical translation. Maybe to get from g of x to h of x, it shifted this direction. So the other way of looking at this is h of x is equal to g, take the x function and minus a negative 2. So x minus a negative 2 is the same as x plus 2. So either one of these translations, adding 2 outside of parentheses or subtracting a negative 2 inside of parentheses, will give you the translated figure. So this could be your answer for the shift that took place to get from g of x to h of x. I'm going to give you some problems to practice, and I will also post the answers. Obviously, it doesn't do you any good to just copy down the answers. I'm not going to collect this for a grade, but I do want you to practice and see if it makes sense to you, if you understand it, and then check your answers on the answer key to make sure that you understood it. If you didn't understand it and you're having problems, please reach out, let me know, and I'd be more than happy to meet with you virtually and help you out. All right, guys, have a great day.